Here we have honors algebra 2 question. That is, we have to sketch the graph of the function y equals to 3 to the power x negative 2 negative 2. It's an exponential function. Okay, so to sketch the graph of this exponential function, I consider the basic function connected to the given exponential function. So that is just y equals to 3 to the x to power. Okay, so now when we compare, first we can sketch a graph of this basic function by plugging in some random values for x. So, for example, let us say x is equal to -3, the first random value for x. When I plug in x is equal to -3, what value do I get for y? So y equals to, we'll be getting 3 to the negative third power because I plug in x is equal to -3. Then it will become 1 over 3 to the third power, which becomes 1 over 3 to the third power is 27. So when I divide 1 by 27, I'll be getting 0.04 approximately. So the first point what I get is -3 comma 0.04. Okay, now I'm going to plug in x is equal to -2. When I plug in x is equal to -2 into the basic function, then I'll be getting 3 to the negative second power, which is equal to 1 over 3 square. Because the exponent is negative, to make this exponent as positive, you have to move this term to denominator. So 1 over the value of 3 square is 9, and 1 over 9 we can use calculator. 1 over 9 gives us 0.111. So the second point is -2 comma 0.11. Okay, now I'm going to plug in x is equal to -1, then y equals to 3 to the power of negative first part, then it will become 1 over 3, which becomes 0.33 approximately. So the third point is -1 comma 0.33. Okay, now what we need to do is we have to plug in the next point, that is y is equal to 0, then y is equal to 3 to the 0th power. So whenever the exponent is 0 for a non-zero real number, so its value is just 1. Anything to the power 0 will be 1. So the next point is 0 comma 1. So when x is equal to 1, then y equals to 3 to the first power, which is 3. So 1 comma 3. When x is equal to 2, y is equal to 3 to the second power, which will become 9. So the next point is 2 comma 9. Okay, I got some random points on the for the basic function y is equal to 3 to the x to power. Okay, now what we do is we have to sketch the graph of this basic function using the points what I've got here. And then I have to apply the transformations for this -2. I mean, where 2 is subtracted from x, where 2 is subtracted from this complete stuff. Okay, before that, we have to do one more thing. Like when I take x is equal to -3, I'm getting a very small value for y, that is 0.04. In case, if I take x is equal to -4 or x is equal to -5, what will happen? Okay, let's see this on the next page. When I plug in x is equal to -4 or -5. Okay, let me draw a real number line. When x is equal to -3, the value of y is equal to 0.04. If I plug in x is equal to -4, what value will I get for y? Then it will be 1 over 3 to the fourth power. 1 over 3 to the power fourth power will be 81. So what do I get if if I divide 1 by 81? It's about 0.01 approximately. If I take x is equal to -5, what value will I get for y? So y equals to 1 over 3 to the fifth power. It will be 1 over 243. The value of 3 to the fifth power is. When I divide 1 by 243, it's about 0.004. Okay, so when I take some large negative value for x in this function, y is equal to 3 to the x to power. When I take some large negative value for x, y is getting smaller and smaller. So here the extreme value on the left side is -infinity. So when x approaches -infinity, y approaches what? So y becomes smaller and smaller because when I take x is equal to 93, it's 0.04. When I take x is equal to -4, it's 0.01. When I take x is equal to -5, 0.04. It's too low. It's too small. So when x tends to -infinity, when x approaches -infinity, y becomes smaller and smaller. That is, y approaches 0. So when x tends to -infinity, y tends to 0. That means whenever x tends to negative infinity or positive infinity, if y tends to a finite value, in this case it's 0, then there is an horizontal asymptote at y is equal to 0. Or this y is equal to 0 can also be said as x-axis. So in this case, for the given basic function, not for the given function, for the basic function y is equal to 3 to the x to power. So there is an horizontal asymptote y is equal to 0, or it can be said as x-axis. So we have to sketch the horizontal asymptote as well. Okay, now, so now we got some idea how to sketch the graph of the basic function y is equal to 3 to the x to power. Okay, now let's see how to sketch the graph of the given function. Okay, here y is equal to 3 to the x to power. Now please understand, so the value of y is 3 to the x to power. Okay, now I'm going to take, actually we don't have x at the exponent, we have x negative 2. So here 2 is subtracted from x. So comparing the basic function 3 to the x to power and 3 to the power x negative 2, 2 is subtracted from x. So once you sketch the graph of the basic function, you have to apply this transformation. That is, when 2 is subtracted from x, you have to do a horizontal translation of 2 units to the right. Whenever your value is subtracted from x, please understand it's an horizontal translation of right. Since 2 is subtracted from x, so it's an horizontal translation of 2 units to the right. Okay, now we have to apply the second transformation, that is y is equal to 3 to the power x negative 2 negative 2. Okay, when I look at the previous case, what is the value of y? This is the value of y. So this one is considered to be y in the previous step. So from y, we subtract 2. Whenever we add or subtract any value from y, so please understand it's a vertical translation. Here we subtract 2 from y. So to apply transformation for this one, we have to shift the graph of 2 units down. That is vertically, we have to shift the graph 2 units down because 2 is subtracted from y. For example, if y is equal to 5 and I subtract 2 from y, it will become 3. So the graph is shifted 2 units down. So whenever we have a value which is subtracted from x, please understand it's an horizontal translation of, here 2 is subtracted from x. So it's an horizontal translation of 2 units to the right. Okay, here you may have a question. What if I have x plus 2? Here 2 is added to x. So it's an horizontal translation of 2 units to the left. What if I, instead of negative 2, if I add positive 2, that is you are adding 2 to y. So that means there is a vertical translation of 2 units up. So in this problem, for this, once we sketch the graph of the basic function, we have to apply 2 transformations. One is for the negative 2 we have with x, and other one is for the negative 2 we have over here. So for this one, we do horizontal translation of 2 units to the right. And for this one, vertical translation of 2 units down. So we have to sketch the graph of the basic function y equals to 3 to the x power. Once you are done with sketching the graph of this basic function, just have to apply these 2 transformations. So then you'll be getting the graph of the given function. Okay, now we can do all this stuff. First we have to plug in the points we got on the first page over here. That is to sketch the graph of the basic function, you have to plug in the 5 points we have over here. So we have to plot these 5 points on an xy plane, and we have to connect them by a smooth curve. Then we'll get the graph of the basic function. So once we get the graph of the basic function, so we have to apply the 2 transformations I have told you. So there is a horizontal translation of 2 units to the right and vertical translation of 2 units down. Okay, now let's continue this one on an xy plane. Okay, here we have an xy plane. So what I'm going to do is I'm going to plot the points what I have found so far for the basic function, that is y is equal to 3 to the x to power. Okay, now let me plot the points. The first point is negative 3 comma 0.04. So that we'll have over here. So this point is very close to x-axis because the y-coordinate at this point is 0.04, which is a very small value close to 0. And the next point is negative 2 comma 0.11, that we'll have over here. And the next one is negative 1 comma 0.33. And the next one is 0 comma 1, which is a y-intercept. And the next one is 1 comma 3. And the next one is 2 comma 9. Okay, now I have to connect all these points with a smooth curve or freehand curve. Okay, let me draw. Okay, I have sketched the graph of the basic function, that is y equals to 3 to the x power. But my aim is to sketch the graph of y equals to 3 to the power x negative 2, negative 2. Okay, so now what I need to do is I have to apply some transformations in the graph of the basic curve to get the graph of the given function, that is y is equal to 3 to the power x negative 2, negative 2. Okay, when I compare 3 to the power of x and 3 to the power of x minus 2, so here 2 is subtracted from x. So whenever a value is subtracted from x, so that is a horizontal translation to the right. Since 2 is subtracted from x, so the graph of the basic function has to be shifted 2 units to the right to get the graph of this stuff, okay? Okay, here you may have a question. What if I have x positive 2? So here 2 is added to x. So this is a horizontal translation of 2 units to the left. If your value is subtracted from x, this is a horizontal translation to the right. If your value is added to x, that is a horizontal translation to the left. So in the given function, 2 is subtracted from x. So this is a horizontal translation of 2 units to the right. So that is we have to shift the graph of the basic function 2 units to the right. Okay, apart from that, we have one more negative 2. That is 2 is subtracted from this complete stuff. So this negative 2 says vertical translation of 2 units down. So whenever there is a value subtracted from the complete stuff on the right side of the given function, so there is a vertical translation. If a value is subtracted, then the vertical, that is the graph of the basic function has to be shifted down. If your value is added to this complete stuff, the graph has to be shifted up. Anyway, so up or down, it's a vertical translation. Since 2 is subtracted from this complete stuff, so the graph of the basic function has to be shifted vertically down by 2 units. So to get the graph of the given function, I'm going to apply 2 transformations in the graph of the basic function. That is, I'm going to shift the graph of the basic function 2 units to the right horizontally and 2 units down vertically. So okay, let me do this transformation for each point on the graph of the basic function. So the first point I'm taking over here, that is 2 comma 9. I'm shifting this point 2 units to the right and 2 units down, then allow the point over here. And now I'm going to shift this particular point, that is 1 comma 3, 2 units to the right and 2 units down, then allow the point over here. Now I'm going to shift the point 0 comma 1, 2 units to the right and 2 units down, then allow the point over here. Okay, now I'm going to shift the point negative 1 comma 0.33, 2 units to the right and 2 units down, allow over here. And when I shift this point 2 units to the right and 2 units down, allow that point over here, that is negative 2 comma 0.11. And when I shift negative 3 comma 0.04, 2 units to the right and 2 units down, allow that point over here. Okay, now I have to connect all the green points with a smooth curve or freehand curve to get the graph of the given function. Okay, now I got the graph of the given function. So this green color graph is a graph for our function y is equal to 3 to the power x negative 2, negative 2. So I have sketched the graph of the function y equals to 3 to the power x negative 2, negative 2. So here we have to notice one more important thing. For the basic function, so the horizontal asymptote is y equals to 0 or x-axis. Because when I plugging in some huge negative value for x into this function, for example, when I plug in y is equal to negative, I plug in a very large negative value for x, that is negative 100. I'll be getting y is equal to 3 to the power of negative 100. It will become 1 over 3 to the power of 100. I divide 1 by a very large positive value, so it will be very close to 0. So when x approaches negative infinity, y approaches 0. That's why we consider y equals to 0 as the horizontal asymptote. So y equals to 0 is the horizontal asymptote for the basic function. So since we shifted the graph of the basic function 2 units down, so for this function, for the given function, so the horizontal asymptote is y equals to negative 2. The reason is the basic function has been shifted 2 units down, vertically 2 units down. So the horizontal asymptote y equals to 0 becomes y equals to negative 2 for the given function.